I made it out of other stuff.
Yeah, this is what I grew up with as blackboards.
Yeah.
This is what people use for blackboards. And you can see it splits very nicely.
Very nicely. Those can be in the picture. Everybody can be in the picture.
Okay, this is a typical example of a low-grade metamorphic rock. Unfortunately, it is metamorphic to the point where you cannot see any original sedimentary features at all. You cannot see the bedding here. It was a very uniform rock when it was a sediment. If there had been some real disuniformities in it, you would actually get to see the bedding. But it was a very uniform, featureless mud. Deep water. Why deep water? Because shallow water moves around a lot, and you get sand, you get clay, it gets different things at different times. Deep, quiet water is just a gentle settling of clay. This is supposedly the deep water rocks, deep water sediments that was off the coast of North America, on the continental slope of the North American continent, in contrast to the African stuff we saw over there. A little further that way, just a little bit further, we get to see the shallow water equivalent. During the collision, at the end of the Paleozoic, the African stuff hit from the east. The stuff in the deep water was pushed up and over onto the edge of the continent by another thrust fault, by another fault. That fault is maybe a quarter of a mile that way. And when we see our next outcrop, you'll be able to see the difference between the two types of sediment, the shallow water and the deep water. The age of this supposedly is maybe 450 million years old. As near as I can tell, that's one of the ones that's a guess, because you cannot get a radiometric date on this, and there are no fossils in it. And you can't trace the rock to anywhere else where you can get a good date, because it's completely surrounded by faults. So in the absence of any evidence otherwise, and by the fact that you do find similar rocks like this that are supposedly 450 or so million years old, they make the guess that this one is too. However, do not put much faith in that at all. This is one of those where asking for the evidence is a really good idea. They may be right. They may not. We do not know. This does not show much complication. This rock does have a very good foliation. That's part of the definition of a slate. It's got to have a really good foliation that is cleaved into thin sheets. But the foliation itself isn't folded. It has not really been through much complication the way we saw at our previous one. And so this would fit very nicely into the Appalachian mountain building period and the Appalachian deformation caused from the collision during the Paleozoic. Now, there is obviously one kind of rock over there, that light gray slate. There's also this white rock up here. Anyone have any ideas what that white rock might be? Anyone want to take a guess? And it's just a guess. Okay, sure.
Quartz?
Quartz. Yes. Anytime you see a white rock, if you say quartz, the odds are good for you. Unless you're in Kentucky or Indiana, and then it's limestone. But if you're around here, odds are good that it's quartz. And that again, that's pure, fairly pure quartz. Quartz does not melt until you get up to a fantastically high temperature, so that's not an igneous rock. It's as I said for the other quartz veins, it's a hydrothermal rock. When this area was undergoing low-grade metamorphism, some of the water was driven off from the sediments at a few hundred degrees. A few hundred degrees. Water boils at 100. How can we be driving it off at a few hundred? This is under pressure. And some of you might have used a pressure cooker. If you use the reason you use a pressure cooker is because if you put water under pressure, it doesn't boil until you have a higher temperature. And so you can cook things faster in a pressure cooker. Okay? If you are 5 miles deep underground, you're under the pressure of 5 miles of rock, which is a lot of pressure. And water under those conditions actually will not boil at all. It'll just gradually get less and less dense without ever turning to what you would call steam. And that particular hot water will dissolve quartz very, very nicely. When it cools off, it deposits the quartz again in veins. And that's what the white rock is that you see here. Okay, any questions? If we have no questions, then pick up a piece of slate if you want a souvenir, and we'll go on to our next stop, and we'll take a look at some of the shallow water rocks which are being deposited at presumably the same time. I say presumably.